A single sheet of paper is made up of matter, which means that it has mass and it has volume. Now, we can easily demonstrate the mass because it falls back to the earth. And we can also calculate the area, but what about its height? How do we calculate the volume of something so small? Well, one way we can do this is by measuring the volume of this stack of papers. Now, I know that the width is 8.5 inches wide, 11 inches long, and then 2 inches high. So, calculating the volume of the stack of papers gives us 187 cubic inches. And we know that there are 500 sheets of paper in this stack. So 187 divided by 500 gives us 0.374 cubic inches in this single sheet of paper. So that also confirms that this sheet of paper is made up of matter. Hey, Enid!
What's up?
I just calculated the volume of this single sheet of paper.
Oh, cool. How'd you do that?
Well, I calculated the volume of the stack of papers and then divided it by the number of sheets.
Huh. Mm-hmm. So, you know, that has me thinking. I've been trying to find a way to measure the surface area of a pin.
A pin?
Any ideas?
Yeah, give me a minute. Mm-hmm. So you mean like this kind of pin?
Exactly. So you see, the body is a cylinder, but the width is too small to measure.
Look, I have an idea. So if we measure a 1-inch line in this piece of clay, then we can calculate how many holes fill in that 1 inch.
Oh, I get it. So if we fill the line with pinholes, then we can count the number of holes that fill 1 inch. So. All right, so I counted 28 pinholes in 1 inch.
So that means the diameter of one hole is 1/28, and the radius would be half that, which is 1/56. So the circumference, which is 2 pi r, would be 2 pi over 56, which gives us 0.112 inches.
Cool, so let me see this ruler. The height of the pin is 1.5 inches, so the lateral surface area would be 2 pi times 1.5 divided by 56, which would equal 0.168 square inches.
And the area of the two bases, which is 2 pi r squared, so that's
2 pi r squared, and that equals 0.002 square inches. So the total surface area would be 0.170 square inches.
That is amazing.
Wow.
Like, this process could be used to measure all kinds of different things. Like, what is the weight of a single bean in a beanbag?
Wow. Did you destroy your beanbag chair just to find this out?
Sure did.
So we could measure a thimbleful of beads, and then we could count the beads, and that way we would know how many are in a certain volume.
And then we could calculate the volume of the bag. And since we know that the bag weighs 1.25 pounds, there's a bit more steps to the process, but it's easier than weighing a single bead.
Cool. So we could use this process to measure really large things too, right? Like the air volume in a concrete block wall, for instance.
Wait, what do you mean?
Well, you know those concrete blocks have some airspace? Here, I happen to have one. You know, just laying around.
Oh!
Oh, yep. So you can see that this concrete block is hollow. And if we measure the air volume in a single block,
We find how many blocks are in the wall.
exactly, then we can measure the air volume by that number, and we have our answer. Really cool.
It is really cool.
So why did you want to measure the volume of a piece of paper?
Well, you know, I was just curious. It really wasn't a weighty matter.
What else can we measure? Let's measure, let's maybe a dog hair.
Let's go find Etta.
Let's go find Etta. Etta!
Hi, honey.